Magnetic field, the direction of the current is 30 degrees with respect to the direction of the magnetic field. Determine the force on the wire. Most of you got this. F equals I delta L V sine theta. Vector in some k direction. Equals. Current is 2, delta L is 1, V I didn't give you, sine 30 degrees, k direction. Force, this comes out to be 1B in some k direction. Take a note to yourself. Force is a vector. Now, I was inclined to take off points. I did not. So you'll see X and I was corrected. So, as long as you got the B for an answer, but remember it is a vector. Technically, to write force down, some of you did say in some direction. That's fine. But I require an arrow. Any questions how to do it? Directly. Problem number 2. A very long wire carries a current of 10 amps. A 3-meter wire is placed next to it. If the shorter wire carries a current of 2 amps in the same direction, the wires are parallel to each other and 0.05 meters apart. Determine the force between the wires, indicating if the wires are attracted or repelled. Long wire, short wire. The field produced by this wire is found from Ampere's law. B equals mu sub naught I, that's the current in this wire, over 2 pi r. And the magnetic field comes out to be 402.1 times 10 to the minus 7. Hey, by the way, I had to correct something I said. I told you mu sub naught was defined as 10 to the minus 7th. I was wrong. It's 4 pi times 10 to the minus 7th. It is a constant. It defines the coulomb. I was wrong. It's 4 pi times 10 to the minus 7th. That's where this number comes in. F equals I delta L V. If you work that out, F comes out to be 2.4 times 10 to the minus 4th in some direction k. Okay. We put the I here at 0.05 here. You have this number here. This I here was 2 amps. So this wire here, this current here is 10 amps. This one here, I, is 2 amps. Any questions about that? Pretty straightforward. Number 3. A proton is fired in a uniform magnetic field of 5.5 Tesla. Proton has a velocity of 100 meters per second in a direction perpendicular to the magnetic field. Determine the radius of curvature of the proton. And we have R equals mv over qv. And you simply plug in the mass of the proton, the charge on the proton, magnetic field, and the velocity. You get 2 times 10 to the minus 6 meters. Technically it's a vector. So R in some vector, let's call that the I direction. And you look up mass of the proton, charge on the proton, velocity, and you get it. So pretty straightforward. Total number of points, maximum is 3. You got 0, 1, 2, or 3. Okay. Again, I did not take off. I was tempted, but I didn't take off